So the X method is the style of factoring that, to be honest, you guys are all really comfortable with. I'm going to put an example up here that I expect you guys will all do just fine with. So give me a second to get that. So if I were to ask all of you to factor this polynomial, I would expect that you guys would all set up an X, multiply A and C together for the top, use B for the bottom, and factor the way that you guys all already know how to factor. So do that for yourselves and we'll check the answer. So the way the X method factoring works, and you guys have all gotten pretty good at this, you take the values of A and C, the coefficient of x squared and the constant term, and multiply them together. So we have a negative 10 on the top. On the bottom I take my B term, that's negative 9. I need two numbers that multiply for the top number, add for the bottom number. I'm going to go with negative 10 and positive 1, because those multiply for negative 10 and add for negative 9. Now this is the key, and this is the part I really need you to pay attention to, right? Because sometimes we skip this part, sometimes you guys sort of like, meh. What do you do with those two numbers? So, and I know you guys see you plug them back in. We sort of use them to rewrite the middle term, right? So if that was originally negative 9x, how do I write it now?
Now you got 2x squared.
Now it's negative 10x plus 1x. And then, of course, we still bring down these two terms here. We still have the 2x squared, and we still have the minus 5. But what I really wanted to draw your attention to was all I'm doing is rewriting the middle term. And then from this point, it's easy. We just group stuff together, right? If I group together these first two terms and these second two terms, what do the first two have in common?
2x.
I can factor out 2x, and I'm left with x minus 5. The other two
1.
seem to have nothing in common. When that happens, we simply factor out a 1, and I'm left with x minus 5. And at this point, I've mentioned before, we sort of get this built-in check. At this point, these two expressions should be the same. If they're not, something's wrong, go back. Right? But they are the same. They are the same. So I just pull these two terms together, 2x plus 1 times x minus 5. And yay, we're done with the x method.
Yeah.
X method.
No, you gotta get
I'm glad somebody brought that up. Do I need to set these equal to 0?
Yes.
No.
No.
Because the original, this original problem didn't say equals 0, solve for x. It was simply a factor the polynomial. We factor it. If the problem doesn't have an equal 0, then you don't need to solve.
What if we do?
If it had been equal to 0, then yes, we'd set each of them. So yay, now that we remember the x method, there is one strange direction this problem can go, and I'm going to show you guys one of those next. So what about this problem? What about 6x to the 4th minus 7x squared plus 2? Is this problem the same as what we've done with before? Is this different? Like, what's the story here? I know this problem is a little bit weird because the powers are strange, and we've already mentioned this. This is a 4th power. This is a squared power. This one doesn't have any x at all. But when there are three terms in a row, when it's a trinomial, x factoring is generally your best bet. So I'm going to treat this problem just like I did the previous one. What's the first step? First step is on the top we put 12, and on the bottom we put negative 7. At this point we're supposed to find out, okay, so what multiplies for 12 and adds for negative 7? Those numbers are negative 4 and negative 3. And then again, I asked you guys to focus on the last example. What do I do with those two numbers, negative 4 and negative 3? I'm supposed to use those things to split up the middle term. So, exactly. So they'll each get an x squared. This time it's going to be 6x to the 4th in the front minus 4, not 4x, but 4x squared minus 3x squared plus 2. And to be honest, from this point on, the problem is exactly the same. All you have to do is group together the first two terms, group together the second two terms, and factor out the common factors. In fact, if you're feeling bold, do that. So the first two terms both had a 2x squared in common. So if I factor that out, I'm left with 3x squared minus 2. The second two didn't have anything in common, and because the signs are backward, I'm going to factor at a negative 1 and be left with 3x squared minus 2. As I say all the time, these two things should be the same. Because they are the same, I can just write that down times the other two factors put together, 2x squared minus 1. And you're done. The question was asked, does the order matter? I know, and most of the time, to be honest, I think I usually write the 2x squared minus 1 first. But the reality is it doesn't matter which order you write them in. Either one of those is acceptable. Now, something that I should point out is that we might not be done. If either one of those had been difference of squares, for instance, what if, and I'll do this in red because it's not, but what if this one had been, what if it had been x squared minus 1? Then we'd actually keep going because that's difference of squares. We could write that as x plus 1, x minus 1. So just be aware. Sometimes just factoring once isn't enough. Occasionally you actually need to factor the thing again to make sure you've got all the pieces broken out of it.